To multiply radicals, we typically use the fact that the nth root of a times the nth root of b is equal to the nth root of a times b. However, this rule only works if the indices are the same. So how do we multiply radicals that have different indices? Well, the answer is kind of simple. We just use the fact that the nth root of a is equal to a to the 1/nth power. So how does that help us? Let's see how it goes. So we're going to multiply the square root of 3 times the cube root of 4. So first things first, I'm going to rewrite the square root and the cube root as 3 to the 1/2 power times 4 to the 1/3 power. And then from here, I'm going to try and combine these two fractions. But to do that, I need to have an LCD. So with 1/2 and 1/3, I know that the LCD is a 6. So for 1/2, I'm going to have 3/6. And for 1/3, I'm going to have 2/6. Now, how does that help me? Well, both of them have a 1/6 in them, technically. So I can actually factor out a 1/6 exponent from both of these. And when I do that, I'm going to have 3 cubed times 4 squared, all to the 1/6 power. Now I can multiply 3 cubed and 4 squared, and I'm going to get 27 times 16, all to the 1/6 power. And now it's pretty easy from here. 27 times 16 is going to give me 432 to the 1/6. And since I was dealing with roots before, I'm going to end with roots. So I'm going to take the 6 and move it back to the front, and I'm going to get the 6th root of 432. So when you multiply these two radicals together, even if they have a different indice each, comes out to this. Next we have the 4th root of 3 times the 8th root of 5. Just like before, I'm going to rewrite the 4th root and 8th root as 3 to the 1/4 times 5 to the 1/8. And now I need to get a common denominator for each fraction. In this case, the LCD is going to be 8. So 3 is going to be rewritten as 3 to the 2/8 times 5, still going to be to the 1/8. No need to change it, so just as is. And just like before, I'm going to factor out a 1/8 because that's what's common to both of these. So I'm going to have 3 squared times 5, all to 1/8. And now, just work on what's inside. I'm going to get 9 times 5 to the 1/8, which is going to give me 45 to the 1/8. And finally, again, because I had roots here, I'm going to end with roots, so I'm going to move the 8 back in front as the index. So I'm going to have the 8th root of 45. And that's what happens when you multiply these two radicals together with different indices.